Welcome everybody. It's a bit packed. The organizer also didn't expect people to actually like this topic, but I'm very happy that you showed up, and I hope you can bear with me in the session. I hope you had enough coffee now, so that should be good enough after the break. We're going to talk about code reviews. I'm going to show you how to facilitate better code reviews and how to use some tools to automate parts of it. My name is Paco from Beckhoven. I've been working for the past 10 plus years as a Java developer / full stack / whatever you name it. Also as a consultant, so I've seen quite some companies, also in the Netherlands. I saw quite some Dutch attendees, so I'm very happy to see that. Yay. I currently work in Switzerland as a software engineer at Hexagon's Innovation Hub. They paid for me to be here. That's very nice of them. I work on HXDR. It's an online platform for... It's a cloud-based platform that allows users to explore and create large 3D models and a lot more around that, but also feel free to forget that. I'm mostly here because I really like code quality, and I like to talk about code quality and all things around that, automating processes. So, enough about me. I thought this was a nice number to start the presentation with. It's not my salary. No. 316 billion was the estimated cost of bugs in 2013, according to a couple of researchers at Cambridge University. This included the time it cost of finding and fixing bugs, and this was in 2013, so given inflation and a lot of things, probably be doubled by now. So one of the things we can do to reduce this number is to find and fix bugs earlier, because it's quite known, I think, who has seen this graph before? The idea is that, and it makes sense, right? The longer it takes to find a bug, the longer it also takes to find the cause of it and to redesign, retest, and everything. One of the things we can do to reduce bugs early is find bugs early is by code reviews we do somewhere around the coding testing process. There's of course many ways to do this early in the process. I'm just going to focus on code reviews. Now, what is a code review? So, the important part that I just mentioned, of course, finding and fixing bugs early, but there's actually more to it. That's also very important. It's about learning and coaching new employees or learning from each other, being aware of what is happening in the code base. And it's also about improving code quality. And I thought, hey, that deserves its own definition, because code quality is always a vague thing. It's still vague, but it's more about making code more readable, efficient, in line with standards, conventions, and best practices. Now, code reviews all sounds great. So we still sometimes hear this. And no, I know there are some nuances to this. So yes, there's people that heavily invest in pair or mob programming. There are small teams or people that is just one developer, then it makes no sense to do code reviews. But for now, we're going to continue with the fact that code reviews are needed. And how can we now incorporate this in our development practices? So what we do, we have this thing called pull requests. And I already did a quick poll on the app, but just a show of hands, is it called a pull request or a merge request? So the nice thing here is that you can see all the GitLab users, because they are the only ones that use merge request. I'm also in GitLab, so I have been indoctrinated, forced, and punished if I did not use the term merge request correctly, so don't blame me if I mixed them up. So most version control systems facilitate these pull requests, which is great. I'm also going to refer to them as VCS or version control systems, and they help us, well, create a pull request, do all the management around it, and also have some nice features and integrations. And even though we have these tools, we often still see the less pretty side of code reviews. Because that one pull request that has a great description but still changes half of the project, and then usually is reviewed in 10 minutes if it looks good to me. You have the great feedback that people leave, or sometimes the slack, the fact that people don't really like the review, and you have to wait for a very long time. And there's always the curse of the small pull request, because where that big one got reviewed in 10 minutes, this one went on for 3 days. So how do we address these issues? Now, one part of the solution lies in creating good review-friendly pull requests. And for this, I'm going to assume that your changes will be concise, focused, tested according to everything you did to at least have the code done good. And And one of the important things when creating a review or whenever you create a pull request is to assume that people come in blank. So they don't know what's going on, they don't know what's going on in your head. And most importantly, people also come back to this pull request maybe in half a year to figure out why certain things were done. And then you also don't know anymore. So it's good to add as much context as possible. Now, that starts with a good title. That's the first thing that people see. So what makes a good title? This is not a good title. It's important to add context. So try to, well, where does it happen? I mean, you still can, there's a max line length. You don't want to write a whole book there, but just keep it short. Now, to me, what I always say is that a good title should be self-explanatory, just like a good commit message. So for this, and also usually pull request titles end up as a commit message and also end up usually in the release notes, depending on how you've set it up. So why not apply the same convention? So there's this convention called conventionalcommits.org to create consistent and standard commit messages. So this is also helpful to create consistent release notes. And what's also good is to always include the issue tracker reference, because most VCS tools will automatically convert this to a clickable link so that people can conveniently go to the pull request. Now, next part, the description, very important. So I want to go over some topics that we should add here, and I think the first one is, well, add more to the context. See, this is an extension of the title, because you cannot write a book there, still shouldn't write a book here, but at least add some context about why you're doing this, what's going on, anything they need to know. Now, then also add a brief overview of what has changed in this pull request. Did you make some changes to the database? Did you add some fields here and there so people know what was intended and what to expect? Another one that's often forgotten is, why did you make certain choices? I'm not sure if why is the right word here, but whenever you're writing or creating a pull request, when you're making the changes, you have this thought process in your head. You consider things, and it's that knowledge will be gone, because if you don't write it down, you will forget it, depending on how good you are with your memory before or after the weekend. It's good, anything. Did you consider certain frameworks? Did you consider to do it through A or through B? Just write it down and say why you chose A or B. That people know, they don't have to ask you about it. Save some time there as well. And another one that's often forgotten is the examples. Because it makes sort of more visible what has changed here. And there's not always an example possible, but for example, if you work in the front end, add an example of screenshots of the fields you added or the screens you added. If you're creating a new, if you're changing the API, add an example HTTP request and response screenshots of that. For example, if you add a new datetime field to a response, the format might not always be clear from the code on how it's formatted. Maybe it's the ISO format, maybe it's a different format. Maybe you know that the format is very specific for this other service, and then it's immediately visible, whereas otherwise people have to go into the code and figure out what's going on. And even database queries or changes, if you did a database refactoring, just this is how it looks now. Now the challenge is, of course, to keep it all concise and readable. This is why people don't want to read a big wall of text. They usually also don't. So add some sections, add some bullet points, maybe some emojis to keep things readable. This is also where ChatGPT can be very helpful to just summarize and make it clear. And on top of that, templates. If you're not using templates in your pull request yet, please do. This helps to standardize and make it consistent across repositories. People will more easily find where to look, find certain information in the text. And the great thing about it is that you can add checklists, because we often forget to add or do certain things. For example, if we need to update some architecture diagram, in 1 out of 10, only 1 out of 10 pull requests usually affects actually the diagrams. The other 9 are small refactorings or don't need to be updated, so people tend to forget that this is part of the process. And there's more to it. I also like that it's sort of to make people conscious about the fact whether they did something, like changes are covered by tests, because some people try to take the shortcut and there's already the first checkbox there that if you check it, I mean, you're not going to lie there, right? So, or you lie, or you actually add the test. But just tailor this to whatever your company's needs are. Maybe you need to update the release notes. I found it very useful, and it helps to get more things done or not be forgotten. Now, having created this pull request, start reviewing your own code. If you haven't already done so while committing, it's also a good place. whenever you see your changes in, for example, the diff overview of your VCS of GitLab, for example, it's a different context, and it's easy to spot files that maybe shouldn't have been changed, maybe some previous attempts, some unused variables, maybe some unuseful names, or inconvenient names, suboptimal names, let's call it like that. If you already fixed them now, that already saves you a list of comments, saves some time. It also is a great opportunity to add context to some smaller changes. So in this example, I removed a file that turned out to be unused, but I double-checked why it wasn't used when it was forgotten. So I added a link to that merge request where it should have been removed. This is some research that I did. If I add it here, then the person reviewing it doesn't have to do that research as well twice. So you save time just by writing it down. The more you write down that's on your head, the more easily you can also forget it. It's also nice, similarly, to add highlight some important parts. So if you fixed a bug in a file, that's usually a 1 or 2 line change, but you also decided to fix some variable names, and now you have changed half of the class, then to unconvolute this diff, just add a message just to the 2 line change, like this is the essence, the rest is relevant. They'll be able to see it, but then they also know where to look at. And you can also use this to, within context, ask specific questions to other teams. You integrate it with another team. Maybe you want to get their opinion on whether you use their API correctly. Just tag him in a comment in that part so they know where to look, rather than look at this whole pull request and figure out where your integration is. Now, we also need people to look at this. And in an ideal world, you wouldn't have to ask for reviews. Team proactively check the pull requests if there's any new ones, or you can even round robin assign pull requests just so that people have to fix these things. In practice, people are just not very keen on reviewing. I mean, it takes you away from your current task, what you're working on. You have to switch context, and sometimes it's just, you don't feel like it. So how can you improve this message? The first issue, what you see here, is what we call diffusion of responsibility, or what I used to say, shared responsibility is no responsibility. If you throw this in a 30-person channel, then the chances are that it will not be picked up. People don't feel like it. That's why it's important to add a target audience. Tag specific people, tag a team. Be clear who should receive this message. Then also it's good to add some context. Don't just throw the title in there, but add some context around it so people know, should I pick this up now, or is this something I'm working on? Oh, right, maybe there's some merge conflicts coming on. I will look at it right away. Or maybe that's for somebody, or maybe when I'm done with this. That's same for the deadline, so that they sort of have a sense of urgency. So you end up with something like this, so that people, know the chances of your message being read and being acted upon is a lot larger when you do it like this. And note that people will still forget. People are busy, people are distracted, they read your message while in a meeting. It's okay to remind them, don't get frustrated. And I know you get frustrated, but keep this in mind that you also forget things. Keep on reminding people, it's okay. And as I already sort of said, this goes further than asking for pull requests. Whenever you need something from another team, maybe you need some input, maybe you need some help, add an audience, add some context, add some sense of urgency so that people are more likely to react. Now, hopefully people are looking at a pull request. How do we deal with the feedback they receive? And it doesn't always go as expected. Some people simply lack social skills. Sorry. But there also might be cultural differences at play. I know there's quite some Dutch people in the room. We are, for example, known to be quite direct, which is not always appreciated in other cultures, so we might have to add some fluff around it. But the most important part is to not take it personal. You have to be patient and sort of try to be the bigger person, because in the end that's also what a professional is about, to not let these communication layer sort of get you off your game. In the end, we all have the same goal. We want to build good software and working software. The other thing that you encounter is the sometimes fake feedback. Somebody did the classic fly like a pigeon over your pull request, leave some drops, and then continue. Ask for clarification or suggestions, because you have 2 options now. Try to reverse engineer what somebody meant with this, go over your code 3-4 times, try to figure out what could be improved, or just ask them. But it saves you a lot of time and also makes sense, because it's not the greatest, the bestest comment. And speaking about not wasting time, you also encounter endless discussions, especially once you have people with strong opinions, which you often have, and both parties think they're right. Maybe you are very convinced that you're right, and the other party that you're wrong. Take this offline, because an async, long-lasting discussion in a pull request it's not efficient. But when you take it offline or online in a video call, also report back, because this is often forgotten that, hey, we're gonna have a discussion somewhere and sort of the thread stops. This also goes for Slack or any communication medium you have. Always make sure to report back the results of whatever happened there, so that in half a year you still know what happened, and that the other people that were not there also know what happened. Now, luckily, it's not all that bad. There also will be some useful feedback. So try to also be grateful for that. People in the end took the time and effort to look at your pull request, to go over your changes, and they found things. If you learned something, just go further than just fixed. Maybe tell them what you learned, because in the end, we want to make this more friendly, and friendliness in the end also increases efficiency and the overall culture of the company. So having created the pull request and having had the reviewees seat, as I like to call that, let's switch to the reviewer seat. Giving reviews. Now, it's important to always review in a timely manner. The longer it takes for you to pick up a review, or the longer you have to wait for reviews, the more time is lost usually on merge conflicts, but also on switching context, and features are delayed. For example, what you can do to address this, try at the start of the day to start with a set of pull requests, or say use the first hour of your day to do this, or whenever you're going to pick up a new task. There was another presentation that I don't know which one it was, but they also said usually tasks are ordered by priority. So whatever people are working on by default has a higher priority than whatever task you're going to pick up, which means that it's more important to unblock that one than to start a new task. And it's also, this one. It's about taking responsibility. You have seen this before. That looks good to me after 10 minutes. When you approve something, you should keep in mind that you become the co-owner of the change, which also makes you responsible. And that means that whenever this goes down, when there are issues with whatever was introduced here, people should also be able to come to you to ask, why did this make it to production? So it's in your best interest to also spend time and do a proper review, even though you might not like it, because in the end, you're signing it off effectively. And now when we start, we should start with getting the context. We just spent quite some time on creating this nice review-friendly pull request, so it would be really annoying if people skip that and just straight asking questions that were already answered in the description. So get as much context as you can, maybe the linked ticket, maybe also check the existing comments, because also duplicate discussions are always quite annoying as well. Get as much as you can, and then go further. This, by the way, goes two ways. If all of this is lacking, and you just have that thing we had in the beginning with C title, ask for clarification, because this will not only help you now and save you time trying to reverse engineer from all the change what somebody was actually trying to do, so saves time there, but also in the future when you go back to this pull request and try to figure out what was done. It's very useful to have the documentation in there as well. Note, by the way, that I forgot to mention this, that not every pull request, of course, deserves such an elaborate documentation. If it's a small bug fix, you don't need to do all the whys and the whats, but at least add some context. When does it happen? Now, when we start reviewing, where do we start? It's important to always start with a high-level overview, because as any findings you have at the top will trickle down below. So if you, for example, see that it should not be async but sync, or the other way around, then writing stall commands on the implementation is sort of a waste of your own time, because that will have to be changed anyway, so it's sort of useless unless you really like to show off that you know better. But that won't really get us anywhere. So start with the design, a high-level overview. What is the functionality in the right place? Then also check the functionality. Is it correct? Aren't there already any bugs there? That's what we wanted to spot the bugs early. This is your chance. Are certain scenarios missed? And then you can go another step further. The complexity, could it be improved? Some of the algorithms, the things, maybe the methods need to be split up. And then tests, I put them in bold, because tests are often, when implementing, forgotten. Well, not necessarily forgotten, but at least they get the least amount of attention and love, as I like to say. You just spend a lot of time implementing it, and then some people tend to do the tests at the end, so they take some shortcuts there. And the problem is that it's not only happens there, but we also do this when reviewing. The tests are usually at the end, we just spend a lot of time on the implementation. I also catch myself to sort of think, this should be fine because the test passed. But no, because these tests will also affect you. Like a bad test suite means that, you lack coverage, maybe you're missing assertions. I've introduced bugs and had issues just because somebody else before me didn't take the effort of writing a proper test. And of course, if you're new to a code base, you cannot go over every single scenario. So you sort of hope that the test suite will save you. So make sure that the right fields are asserted. That's one of the things. And make sure that the code is a bit readable. And then at the very end, we can start nitpicking on everything we don't like, but actually doesn't really affect the code base significantly. Now, there are tools to help you. And some of the features of these tools. So one that I particularly like is, for example, GitLab allows you to inline code coverage in diffs. So who has this enabled, code coverage in diffs in GitLab? Okay, nice. Actually, nice. So if you don't, I think it also might be supported for Bitbucket and for some other tools. Typically, if you review something, you also want to know if the test coverage is okay. And that would either be done by going to the coverage report or trying to figure it out from the test. Now, the latter is a lot of effort, so look at the report. I don't think, does anybody here look at the code coverage report when reviewing? Let's see, that's a very small percentage of the room. I mean, I'm happy you do, but it's also still a lot of work because you have to cross-reference the code coverage report with the diffs, have it in line. And there's some other integrations there as well. Like SonarCube, and you can go even further. There's quite some tools. I'll cover a blog post later that allows you to, for example, automatically create commands based on integration. So you can do a lot of things here. But as not everybody has access to these tools. Oh, by the way, the code coverage is only for, if you're using GitLab, it's only for premium users, not for or for Ultimate, but it's the middle tier, just so you know. As not everybody has the tools available or the opportunity to configure this, there's still one very extremely helpful tool, which is your editor. So just to illustrate you this is a diff from, say, GitLab in your nice merge request, your nice pull request viewer. And it looks sort of okay. Sure, we can already argue about some things, but if you take your editor and now look at it, you see a broader context. You see the things around it that might be missed. So in this case, as you can already guess, there's now an unused variable that we would have missed if we would have just looked at the diff. I mean, you can increase the scope, of course. That's usually helpful, but it won't highlight things there. This we can use is empty, which can also be improved. Now, the nice thing, you can always run the tests in your editor with coverage. It's there. It shows you now nicely that this return statement, this new introduced case is not tested. So, hey, maybe a unit test should be added there. And with the latest release of IntelliJ, or I think maybe the previous, you now have the opportunity to integrate. You already had the opportunity to integrate with your visual version control system, but you can also see within the context of the files what has been changed, and also get the comments if you select a certain pull or merge request. Now, besides this, there's also some AI power tool available. I did not really get the opportunity yet to check these, but just know that there are some tools that can already automatically add some comments and do some things there. Feel free to check them. But unfortunately, I haven't. So let me also know if you have tried this out. Then the next step, writing a good comment. One of the things that I often see is the use, or what I actually learned was about using you. Try to refrain from using you. Don't. Because you, especially if you look at this example, can sort of be interpreted as a direct attack. This looks quite unfriendly as a command, and it will make people defensive and less likely to cooperate, whereas a we is more about collective ownership, about collaboration, and it makes people more open, like, hey, we're in this together, we want to fix this. And the same goes for the statements. So you can either make a bold statement, this is wrong, or you can ask, hey, is this wrong? And if you add those two, combine these two, the chances that people are still happy after reading your command are quite higher, and people are also more willing to cooperate, more willing to look for a solution, stay happy. This is very useful. It takes some time to get used to, but once you're done there, it adds a lot of friendliness, and people will be more likely to cooperate. Now, the other things that you can think about is try to be specific. try to stay away from words like this or it. This also goes for the both all the way, by the way, go just not for commands and pull requests, but this is also in generic in your messages. Reread the message, reread whatever you wrote to see if any miscommunication or misinterpretation is possible, because that's usually leads to quite some time wasted because people don't really understand what's going on. And it's always easy to complain and say, I don't like this, but try to also come up with an alternative or to provide an alternative solution. If you already know it, that saves the other person from spending time on it, unless you really want them to sort of struggle and learn, though they will still learn. Or at least put in some effort, because maybe there actually is no alternative solution. I have often seen that some code looked really quirky, and then you try to spend an hour to realize actually that there is no better solution, and the person was right. On the other hand, asking for an explanation would have saved you that hour. Now, another thing that people not always using and should be using more is the use of suggestions. So whenever you place a command in GitLab, you have this second button, I think. The lines you selected will end up as a diff when you click this button. And then you can easily make changes. So that suggestion that we have of equals to is empty. We can already do it in there, so we don't have to write it down if we put it immediately in a diff. So this has two advantages. The first one is the person who has to make the changes don't have to go in the code and make the actual changes, because there's always this apply button, or you can add it in batches. And it saves you time, because you don't have to go over and check and verify whether it was fixed correctly. There is one caveat here, is that, of course, this is not a smart refactoring. So if you start to rename methods, variables, then it will cause compilation errors later on, so you might want to either mention that or maybe not use a suggestion for that case. One of the ways that we can also, as we mentioned before, we had conventional commits. There's also something called conventional commands to sort of structure and make commands more consistent. What I particularly like about this is for example, the nitpick tag. Make it clear to whoever the audience is that the command is either blocking or non-blocking, whether it is of significance or not. Because if it's not of significance, then the person can also decide, okay, I disagree, this is apparently not worth a fight, I'm just going to ignore it. It saves some time there as well, and it's nice to have an overview. I try to practice with this, and it's sort of helpful to give an overview. Now the last part, we already did this when receiving the feedback. Try to find positive things. So pull requests are usually quite a negative place where you only hear what you did wrong, whereas it's also nice to force yourself to find at least one positive aspect. I would say maybe this is not the right way to go, but hey, at least they found something positive. And this really adds, well, again, this layer of friendliness, but it's also in a time where we see a lot of imposter syndrome and people being very insecure. It will help people to boost confidence, to also show that, hey, I learned something from this. Oh, hey, this new method, I didn't know about it. Maybe this was a nice refactoring that you really didn't want to do and somebody else finally picked it up. Just show some appreciation, just again to improve sort of the atmosphere here. Now, we covered the pull request part. Let's go, well, the reviewing part. Let's go to another topic that I promised, which is bike shedding. So, bike shedding, also known as the law of triviality, usually indicates that people spend a disappropriate amount of time on less relevant issues, because that's easier to argue about. We already saw the curse of the small pull request. Whenever something is irrelevant, we like to have a discussion about it, because the complex material requires more brain power. The term bike shedding also comes from a story about a corporate committee that had to discuss buildings, and in the end they spent a lot of time discussing a potential new bike shed rather than discussing the power plant. It's sort of a common thing that happens, but be aware of this, and we can do that by taking away these trivial issues. So, for example, the is equals to is empty. Sure, in the end it's the same. It is mostly about readability, whether you use equals an empty string or is empty. Maybe there might actually be a very low-level difference, but in the end it's all a lot of noise. And all these trivial issues also distract from the bigger picture. People get distracted when they see these small things and they stop looking at the bigger picture. You even have people that tend to, I write down freestyle issues, should be good enough, I'm out, looks good to me. So I want to go over a set of tools that can reduce this noise by automating by automatically flagging and sort of failing builds before we can even create the pull request. And one of my favorite tools for this is error-prone. So I'm briefly going to go over them. There are separate presentations on the internet, and even at this conference, on these topics. So error-prone is a static analysis tool to catch programming mistakes at compile time, something that CheckSty and SonarQube can also do. But the difference here is that this one also provides automated fixes. So it can automatically patch all the issues for you. And that is very powerful. Then there's also a large library of rules and improvements. And Picnic, which the Dutch and Dutch-related people might know, they also created a very large set of extra rules in their Picnic error-prone support library, which also helps code base consistent. Because in the end, error-prone is about if there's 3 different ways to write something, we only want one. We want to bring it back to just one way of doing it, so that we cannot have a discussion, hey, you should use isEmpty instead of isEquals. So to give you some examples, filtering a list of null values. You can do this the top way, but there's also the opportunity to get an error. Hey, at Picnic we wanted to use objects non-null as a reference. Might be easier to read. You can argue about it all you want, but at least if you have one way of doing it, people get used to it and it's done. But there's also optimizations, like big decimal.0 is more performant than big decimal.value of 0. If you automatically get rid of all this noise, then you don't have to argue about this in pull request. You can also find issues with logging. For example, when I introduced this, I also found some rare exception cases that had some issues where we sort of swapped the percentage at with the braces, percentage s with the braces, and the other way around. So for string formatting, you need one. For logging, you need the other. And also assertions. I actually found some of these. So who sees what is wrong with this assertion? Yeah, exactly. And back it was, so what it actually, this doesn't do anything, because with assert that you need to add is equal to at the end. So this might look like an assertion because there are some equals in there, but it's wrong. And error-prone can actually help you with that and automatically delete at is true at the end. Still, you can improve on readability, but hey, this is automatically caught. Now you have to spend less time on finding assertions that are broken like this. And even for readability, in the talk of about ArchUnit, there were some discussions about the way you can write Postmapping in Spring. There, you can do it through @request mapping with method is post, or you can say @postmapping. We're using error-prone and these rules that are already available. There's only one way to do it. Cannot discuss about it. Save some time there. So when you introduce this, test the rules in your code base and sort of choose the ones that match, because for example, Picnic is opinionated to the frameworks that they use, and if you don't use that frameworks, you might not like the suggestions that come out of it. And if you do weird things with Lombok, especially around the super builder construct, there you can do some funky things that it doesn't really like, so you might have to take an extra look at the rules there or ignore them. Now another one, OpenRewrite already has a talk and a presentation, and I still want to mention them. If you haven't heard about them, go check out their booth as well. They have a big set of recipes to do large-scale migration. So if anybody still does a migration from JUnit 4 to JUnit 5 by hand, I would say save yourself the time. You can do it in 1 hour instead of 5 days. And the nice thing, or for example, migrate to AssertJ. Now the nice thing is that Tim Tebeek also wrote a nice blog post about how you can use OpenRewrite to automatically create a set of commands. Already on the pull request, they use this in their open source repository so that when somebody commits something, it automatically already runs some recipes so that if anybody accidentally uses a Java 17 construct, whereas it should be Java 21, there's already automatically a command there. Now, those are relatively small parts. We also have formatting. And formatting is, I would say, the biggest noise in pull requests, especially if you have teams that don't I would say enforce the code style. So you have different people with different code styles, and what you then see is that whenever you're the one that does like a code style, you end up always making way more changes in the file than you sort of intended. This adds a lot of noise. So it's always good to have a code style that's automatically enforceable and to don't deviate too much from industry standards. So what we did, for example, what I noticed when I joined the company, we didn't really adhere to a code style, so everybody just sort of did some standard. And then whenever we had a company standard, but people didn't really use it. So whenever I opened a pull request, I opened it in my editor, formatted all the files that were changed, and then had already one comment, hey, please format these files. Now that we introduced CheckSty to automatically enforce this formatting, I don't have to do this anymore. I save time there. But there's more to help you with formatting, besides creating your own format. As we're at a Spring conference, we have Spring Java format. This is one of the tools that automatically can format your code on the CLI, but this one is not super opinionated, but it does also come with a CheckSty plugin. So if you really like Spring style, then this is a way to go. I personally always go for the more opinionated, the less room for discussion, and for that one you can also use Google Java format. This one is so opinionated that you cannot put a line break wherever you want it, because it will revert it and it will adhere to its style. The more opinionated also comes with the downside that you might not like its opinion. But it's also something that we as people get used to. And no formatter will ever be perfect, and the more strict it will be, the less happy people will be in the beginning. But as always, if we move from one company to another or from one project to another, eventually we get used to it, and then we want the old style back. And then when we go to the new one, we want that one back. So just sort of take the pain and migrate to a super strict formatter, and then you have no more discussions on line breaks. For this, there's also the Format Maven plugin by Spotify, which automatically, this one integrates with Google Java format, so it uses the same style so that you can use it from your CLI and also in your builds to fill the build if the code style is not adhered to. I already mentioned CheckSty. This is also great for naming. So besides the formatting, so if you want to stick with your own code style because there's not enough people on board to actually push it through. I was in that situation, and you can still make a nice set of rules to enforce it, and also other things. CheckSty is good in verifying names, like the constant name. If you're not using uppercases, or maybe the order of methods, you always want the public methods maybe on top. Don't put your constants halfway the code base. Then there's also ArchUnit. There has already been a presentation in this conference by Roland Weisleder, if I said it correctly. Check it out on YouTube. And it's also was mentioned in the keynote as it's used as the base for Spring Modulef. It's a great tool to enforce both architecture guidelines and naming conventions. So if I take an example here, you can write, they have a very nice DSL. One of them is to verify your architecture, where you can say, hey, I have a controller, a service, and a persistence package, given these prefixes. And of course, a controller package cannot directly access the database. The database package should not access any of the packages above, and the service should not call the controller package. You can think of this, and still sometimes it slips through. Somebody's new, somebody took a shortcut, and now you can automatically enforce it and make sure that you don't have to spend time on this during the review. Another thing is naming conventions, and every company has them. Whether an interface should end with interface, whether it should start with an I, or whether all implementations should end with impl. I've seen them all, and in the end, it really doesn't matter. Just pick one and stick to it. And this is the way to sort of stick to that and not have discussions in pull request about it. The same also for other things like the controllers. So how do you identify what a controller is? Okay, maybe it's annotated with a certain annotation or in a certain package. It should end with controller. And you can go even further, like all methods that are in a controller should have a secured annotation on it, because we want to make sure that we verify the right roles. Now, when you go for ArchUnit, there's a large set of predefined rules already available. Have a look at them, and maybe they are useful for you. Use this as well to if you have some coding guidelines in your Confluence page that people sort of tend to forget about. Try to automate as many of the bullet points you have in there with something like ArchUnit, so that you keep it all consistent, and you don't have the need for this one guy that does like it and has to refactor half of the code base to be again according to the architecture guidelines. The nice thing about ArchUnit is also that you can centralize these rules in a central place, so you can write one module in which you put all the rules together, and then you import them from all your different projects so that you have them consistent. Now, with all these tools, there's some overlap. You can do most of the things you can do in Airpro, you might be able to do in CheckSty or in ArchUnit. But try to sort of use this order. The order, at least that I like, is to put anything that you can catch at completion time and which you can get fixes for. try to implement it in there, because that's the nicest play. And whenever you do a migration, you can immediately have all the rules done. It saves time of the person that has to fix these errors. Then go to the compilation layer, still tools like CheckSty and Sonar, just to catch anything that at least you want to fill the build, and the build feels faster, because if you wait all the way into the test, it also takes quite some time for people to get feedback on what was broken. So if you can capture it early, it's better for the feedback loop. Now, when you start introducing these tools to your organization, make sure to start small, and also make sure to have the people on board. What I did, for example, when we introduced error-prone, is I took a couple of repositories, ran error-prone after sort of carefully going over the set of rules, created an example merge or pull request, and have people have a discussion there. Which rules did they like? Which rules did they not like? Maybe they think, if half of the team thinks it's a bad rule, then immediately you can disable it so that there's more acceptance in the team and people are more happy to work with your changes. At Picnic, it even went so far that when I was working there, whenever we had a big stall change or anything that we had either an A or a B option, we had a discussion on Slack, and then first had a Slack discussion, and then at the end there was a poll, and people could just choose, and based on that we either chose left or right. And that's a great way to keep people on board and make sort of the right decision there. Another thing, things like error-prone and CheckSty are quite configuration heavy in your POM file. You don't want to duplicate it everywhere. It's always good to have sort of a centralized parent POM anyway. This is a great opportunity to introduce one to make sure that your team is also aligned on versions, for example, of Spring. One of the tools that I, by the way, forgot to mention, Renovate is also a really nice one. Renovate is a tool to update your dependencies automatically so that you also don't have to be distracted by that in your pull requests. Now, to conclude, it's important to write descriptive pull requests and to review them yourself. Be specific in your audience and also be friendly in your communication. Try to find positives to make people also feel a bit better about themselves. Try to find the positive things. And use features of your editor and also your VCS tool. So if you have GitLab, there's some documentation on how to install code coverage in your diffs. It's super nice. And most importantly, also stop bike shedding and just start automating as much of this as possible. Now, to quote my old boss, please also leave a rating in the app. Be honest, but also be generous. And that's it. Thank you. So I hope you're still alive. There were a couple of questions in the app. I think one of them, if I get it to work, already answered. So should code review focus more on clean code than to adhering to guidelines? So code and guidelines versus the actual functionality. So code review should really be about the core of the changes, about the functionality, and that's why you try to automate any of the other things away. But are there also any questions from the audience, actually? This might be better. Yeah, you go first, and then you. Yeah. Yes. So,
for example, I noticed that external resourcing company, they are less prone than write long documentation on the PR and so on.
Okay, so the question is, or did you notice that externals tend to be less likely to cooperate in the coding standards? Yeah. Well, so then a pull request is a nice place to tell them to fix this. And it really depends on the externals, because there's also plenty of places where it's the externals that bring in these practices for the team to adhere. So try to keep on giving feedback and pull requests on this, or just hire another external. Yes?
You can talk about resolving threats. Will the person who opened the
Yeah.
request ever be allowed to resolve threats themselves, and how to make sure they didn't just ignore, resolve,
Yeah. So the question is about how do you deal with all these commands? Should people be allowed to, who should resolve them? And how do you deal with any unresolved threats? What we do, it really depends on what the team likes. I have seen places where we always need them to be resolved by the person who placed the command. So then that you can sort of verify that it was actually fixed. But then also use things like to indicate that it's free for the person that is making the changes to resolve them, if you want to block people. And always, what you can do is also block pull requests. that they should not be mergeable if there are still open commands. So if you use these two rules, then people cannot just merge whatever they want. They need people to review it and the reviewer to also resolve the comments if they are fixed.
The problem was the one opening the pull request wasn't resolving threads without addressing big topics and then probably merging. So how
Yeah.
do you block that?
So most VCS tools have the option to not allow merging if there's still open commands.
Who should resolve? That was the question.
Oh, so who should resolve them?
Yes, because if the person wants to merge fast and just resolves them without waiting for the reviewer to see did the person actually
Yeah.
address this issue, then that's where the conflict lies many times.
Yeah, so there's the issue that people still just resolve all the feedbacks without actually looking or fixing them and pressing the merge button. So I think this is a great place to have a conversation with this person's manager and to talk about how we want to work as a team. Any questions?
Yes, I have one. On the session description on the website of Spring Guy, you are talking about a statement, the value of self-reviews. I would like to, it's quite interesting to understand.
Yeah, so I covered the self-reviews in the beginning, and it's quite valuable. I learned that doing these reviews yourself, if then people, when I was looking at reviews of which people already added some context and reviewed their own pull request, added some extra mentions of things that were done, that it's much easier to review it and you can go through it much faster because all the questions you might have are actually already answered because hey, the knowledge was already there.
You mentioned error prone because for the suggestions and then compile them. But are you thinking about SonarLint and during there you have also the suggestions during the conversations? So what is your opinion?
So the question is, so we discussed error prone, but how do we deal? What about SonarLint, which can also sort of? I'm not sure if SonarLint also gives you the opportunity to automatically fix them. And then, if I would compare, because indeed SonarLint can probably flag most of these issues as well. If you have one tool that can automatically fix them for you, and one tool that just complains about them. I mean, even in real life, if somebody can also fix your issues, I would rather use that tool than the tool that just tells you that is wrong. But you can use both. If SonarLint you can stack tools and just have them be additional to each other. Just make sure that they don't overlap. So if your rules are error prone, don't enable them in Sonar.
How do you manage that command need an interaction? I mean that you make a review, you make the commands, the person leave another command, but you switch on another task. How do you know that you should take this review again to answer the second command?
So the question is about how, so you leave a review, then somebody starts commenting on them, but in the meantime you're already working on a different task. There's different ways to do it. I personally enabled GitLab notifications in my email, and I sort of look at them because I want to unblock whoever. Yeah. But there are always, indeed, that depends, you have to tailor your notifications because that might indeed be an inbox of thousands of emails. Either have that person ask you to do another round, because that's the way to work as a team. I try to be proactive and sort of already get notified that somebody's making changes so that I can immediately help them to get this process through faster. Because in the end, we want to get these reviews done as quick as possible to get features more nicely done. More questions? Okay, one more. Yeah. Okay. So how do you deal with error prone if you have a giant repository and you want to introduce it? Yeah, that's a good question. So I put in quite a manual effort to go over when introducing all these pull requests. I really liked it, so I just ran error prone and manually reviewed all of them. If that's 400,000 lines of code and 10,000 of changes, that might not be worth it. So then it's good to first take a smaller part of the code base. Maybe, I hope there's smaller modules in there. Start with a submodule and have the team discuss on the rules. Try to get the team, at least that the team is in line with the rules that you've set up. And then at some point, because if the code compiles after error prone has run, the changes that error prone suggests should be still the same. So whatever it was before and whatever it is after should be functionally identical. So then you should be able to rely on the tool and be able to create one giant pull request that people can go through as much as they like, do it in your editor, then you have this nice F7 button to go over the changes quite quickly. But then just trust the tool. But first make sure you have the trust in the tool. Okay, I think we're out of time. Thanks a lot for being here, and I'll be around.